So what we were looking at, we were working in the context of a modified theory of gravity called f of t gravity, and we were interested in constructing a solution which represents a black hole without the singularity at the center. And we are able to do this because we can modify the theory in such a way that on very small scales the theory changes by no longer being locally Lorentz invariant. And this change of small scale effectively removes the singularity that is at the center of a black hole in standard general relativity. What is key to our study was the following observation. So it is well known that the Schwarzschild solution inside the Schwarzschild horizon can be written in such a way that it looks like a cosmological solution. For our model, f of t gravity, it has been known that the cosmological singularity can be removed by studying particular models. So we suspected that if one looks at the interior of a black hole, rewrites it as a cosmological solution, we should be able to achieve a similar feat, removing the singularity. And this is precisely what we have been able to do. So our singularity is blown up effectively to a finite size and hence making it regular. And what is nice about our solution is we have complete control of this solution in the sense that we can send a certain parameter to 0, and then we can have a smooth transition from our solution to the general relativity solution, which has a singularity. Because the center of the black hole is no longer singular and has sort of been inflated to an object of finite size, we can compute various curvature quantities near this point, and they all turn out to be regular. Because of the finite size object, this finite size simply gives us quantities that are in a sense proportional to the smallest quantity, or 1 over the smallest quantity. So if the smallest goes to 0, those quantities would blow up. But in particular, we can show that objects like the Ricci scalar are finite once we approach this, well, the new center in the sense of the black hole. And it is because of these observations that we can say that we think that this space-time is geodesically complete, because every geodesic can travel through space and there's no point where it terminates. So one of the nice outcomes of the study is that f of t modified gravities of theory are very useful theories for studying various situations that are problematic in general relativity. And we have a natural way to introduce a new length scale, and this length scale simply can fix problems that exist in general relativity. So for instance, the singularity at the center of a black hole can in a sense be smoothed out by introducing a finite length scale, similar to the situation in cosmology, where this can also be done. And we actually now are interested in studying the temperature of our regular black holes, and again we would expect solutions which are similar to the standard result with a small correction due to the smallness parameter.